Okay, we're going to have a look at prime factorization now. Now, one of the fundamental theorems of mathematics is that any integer, any whole number, can be written as a product and as only one product of prime numbers. Product means a multiplication of prime numbers. So the way we write a number as a product of prime numbers is we divide the value that we've got by the list of prime numbers. We need to know our list of prime numbers: 2, 3, 5, 7, 11, 13. Normally it doesn't go higher than that. Normally, and it would tell us in the question, we would give our answer in index form, so using powers. So we've got three questions to start with. First one, we've got a number which is written as a product of prime factors. We need to work out what number that is. So 2, 3 and 5 are all prime numbers. So this is a way of writing a particular number as a product of primes. Well, let's work out what that number would be. Well, 2 cubed means 2 times 2 times 2, which is 8. So this means 8 times 3 times 5. 8 times 3 gives me 24, so it's 24 times 5. And 24 times 5 is 120. So 120, if we broke it down, would be written as 2 cubed times 3 times 5. So we're going to go the other way now, and we're going to break down 108 and write it as a product of prime factors. And we're going to use a tree to do that. So I'm going to write 108 here in the space on my page. I'm then going to go through the list of prime numbers in turn. So I'm going to look at 2 first. Is 108 divisible by 2? Well, it's an even number because it ends in an 8, so it must be an even number, so 2 does go in. So I'm going to put 2 there on one side of my branch, and I'm thinking, how many 2's are there in 108? Well, 2's in 10 go 5 times, 2's in 8 go 4 times, so it's 2 and 54. Okay, I'm then going to have a look at my list again, and I'm going to see, does 2 go into 54? Well, yes it does, because it ends in a 4, so it's an even number. So I'm looking at how many times does 2 goes in. 2 goes into 5 twice, remainder 1, and 2 goes into 14 7 times. So I've got 27. Now, I'm going to look at my list again. Does 2 go into 27? No, it doesn't. It's not an even number, it's odd. So I'm now going to try 3. Does 3 go into 27? Yes, it does. If I go up in my 3 times table, 3 times 9 is 27, so I'm going to put 9 here. Again, I'm going to say, does 2 go in? No, it doesn't. I've already checked that. Does 3 go in? 3 does go into 9, so I can break down my 9 into 3 and 3. And at this stage, I can go no further, and it's a really good idea to check. Are all the numbers at the bottom of my tree, are they all primes? Are they all part of this list? They are. They're 2's and 3's. So I can write 108, and you do need to write this out in an exam, equals 2 times 2 times 3 times 3 times 3. Now, if I was going to write that, if it asked me in the question to write it out in index form, well, 2 times 2 is 2 squared. 3 times 3 times 3 is 3 to the power of 3. So I can write it as 2 squared times by 3 cubed. Okay. The last question is an interpretation question, and here these are quite difficult for us to get our head around. So they give us a known fact here, and they tell us how we would write 450. We need to use that to write 4,500. Now, if you did your full working out using a factor tree, you might not get any marks at all if it tells you to use the information you've been given. So what I need to realise here is that 4,500 is the same as 450 times by 10. So here I'm just going to write that 4,500 equals 450 times 10. Well, I'm already told that 450 is 2 squared times 3 squared times 5 squared. That was part of my question. So that's my 450. Now, 10 is just 2 times 5. So I'm just going to write that in black. Times 2 times 5. So I can now use my power rules that we looked at in the last lesson to simplify this. I've got 2 squared times 2, which is just going to give me 2 cubed, times 3 squared, times 5 cubed. And I've used the information that they gave me in the question to make a shortcut to finding the answer. Alright, take a second just to write those worked examples down, and then I'll give you some questions to do yourselves. Okay, so the first 6 questions for you are just using factor trees to write a number as a product of its prime factors. For question 7, 8 and 9, you've been given some information about 300, and you need to use that to try and work out the prime factorisation of 600, 150 and 2400. So you're thinking of each of these in relation to the number 300. How would you get from 300 to 600? How would you get from 300 to 150? How would you get from 300 to 2400? Alright, take a second to write down the questions, and while you're doing that, pause the video and then we'll come back together for the answers. Okay, and there we have our solutions. 2 cubed times 5 squared for the first one, 3 times 5 times 7 for the second, 2 squared times 13, 9,000 was a bit of a tricky one, you might have needed more space, 2 cubed times 3 squared times 5 cubed, 792 was 2 cubed times 3 squared times 11, 5625 was 3 squared times 5 cubed. For the last part of the question, you need to recognise that you were multiplying this number by 2, so you're adding 1 to the power. So it would be 2 cubed times 3 times 5 squared. Here you're dividing by 2, so you're taking away 1 from the power of 2, which gives you 2 times 3 times 5 squared. And for the last one, you're multiplying this number by 8, which is multiplying it by 2 cubed. If we see down here, so you're adding another 3 to that power, which gives you 2 to the power of 5 times 3 times 5 squared. If you have any difficulty on these and they come up on a calculator paper, your calculator can in fact do this directly for you. So we're going to have a quick look just at how we do this on question number 9. I'm just going to try and change the lighting a little so that you can see my calculator a bit more clearly. Okay, so I'm going to do this for question number 4. So for example, I'm going to type in number 9,000. And I'm just going to press equal so it's in the calculator memory. I'm then going to press shift and then this degrees, minutes, second, where it says fact, because I'm trying to find fact, so I need to press shift. And there we go, it gives me my answer of 2 cubed times 3 squared times 5 cubed, which is exactly what we worked out using the factor tree over there, so you can always check your answers on your calculator. So I'm just going to leave you there for a second, so pause the video please to mark your work and give yourself a score out of 9. If you need any more help with this topic, please go on to Hegarty clips number 29 and 30. Well done.